Very good morning, students. Welcome back to the maths class. In exercise 2.2, up to 4th sum we are completed. Now we will continue on 5th sum. Without actual division, find which of the following rational number have terminating decimal expression. It's very important to look at its denominator. Here the denominator is 128. So prime factorization, take 128, do the prime factorization, 2 tables, 6 times, 4 times, and again 2 tables, 32 times, again 2 table, it is nothing but 16 times, again 2 table, 8 times, 8 2s are 16, again 2 tables, 4 times, 4 2s are 8, again 2 table, 2 times, 2 2s are 4. Again if you do 2 tables, you will get 1. So this 7 by 128 we can write it as 7 by 2 power 7. 7 by 2 power 7. If the denominator is having 2 powers or 3 powers, therefore we can write it as 7 by 128 as terminating decimal expansion. Why? Because if it is have 2 powers or 3 powers, then we can say it as it is a it is not 3 powers, it is 5 powers. So I will give the expansion. It should be like p by 2 power m into 5 power n, whether the denominator should have 2 power something or 5 power something. If it is like that, then it is called terminating decimal expansion. You keep it in mind. This should be very important. P by 2 power m or into 5 power n. If it is in this format, then you will tell that the number is terminating decimal expansion. If it is not in this format, then you have to tell it is not terminating decimal expansion. Now we will move on to the second subdivision. The second subdivision is nothing but 21 divided by 15. 21 divided by 15. This 21 divided by 15, if you simplify in the 3 tables, it is 7 by 5. Are you agree with me? Yeah, 3 5s are 15, 3 5s are 15, 7 3s are 21. So you will get that as 7 by 15. So it is nothing but 7 by 5 power 1. So it is in the format of by 5 is there. So if the denominator is in the powers 5 powers or in the 2 powers, then it is called therefore 21 by 15 as terminating decimal expansion. Now we will move on to the third subdivision. 4 9 by 35. 4 9 by 35. So here you can take 4 into 35 is nothing but 140. So plus 9, 149 by 35. This mixed fraction we have to convert this into improper fraction. After that, the denominator for 149 divided by 35 is nothing but 5 into 7. It is not in the form of p by 2 power m into 5 power n. You can look at us. It is 5 power n is there, but it is not 2 power m is not there. So some other number came, it 7 came. So therefore 4 9 by 35 as it has non-terminating recurring decimal expansion. The last subdivision is 219 by 2200. So we can't able to simplify this. So no other way, we have to take prime factorization for the denominator 2200. So 2 times it will come 1100. Then again go for two tables, 550. Again go for 2 tables, it is 275. Go for the 5 tables, it is 55. Go for the 11 tables, again 5 tables, it is 11. Last you go for the 11 tables, it is 1. So you have to write this 219 by 2200. We can write it as 219 by 2 power 1, 2, 3. 3 2's also there. So 2 power 3 into 5 power 2 5's are there. So 5 power 2 into 11 power 1. So you might have note that it is not in the form of p by 2 power m into 5 power n. Sir, it is there, sir, 2 power n and 5 power 1 is there, sir, but it included 11 power 1. So 11 power 1 is extra. So therefore 219 by 2200 as a non-terminating recurring decimal expansion. Are you able to understand, children? Yeah, now we'll move on to the next question. Yeah, now children we'll moving to the exercise 2.3. So in exercise 2.3, the first sum is represent the following irrational numbers on the number line. We know how to represent a rational number on the number line, but it is an irrational number that we need a geometry box, geometry things, etc. So I am not going to do this sum, these 3 subdivisions now. After completing this chapter, we will move on to this geometry part. Clear, children? Now we will move on to the second sum. Find any 2 irrational numbers between 0.301, 0011, 000111 and 0.302002002. So here is this subdivision 1. So what you have to write? 2 irrational numbers between the given 2 rational numbers are, sorry, but this is also irrational numbers. Irrational numbers are. So irrational number means it should not terminating and it should not repeating. So you have to write a number like this. After this number, what the number will come? You think over that. 0.302. Here 0.301 is there. The next number is 0.302. 0 and 3012. Sorry. 0.3012. So 3012 022 00222. What is the next number? Next number of this? And 0.301 30 3300 333. So instead of the place, instead of after this 1, you have to write 2 for the first number. For the next number after this 1, you have to write 3. 3033 00333. Just without any rules and regulations. Then just you have to write the numbers that should not repeat, like that only. And also it should not terminate, it should move on. So these are all the 2 irrational numbers. So now we will move on to the second subdivision. The second subdivision is nothing but a fractions, that is 6 by 7 and 12 by 13. Yes, listen here. The second subdivision is 6 by 7 and 12 by 13. So you have to divide it 6 by 7. So it is less than 7. So you have to put a point in the question place. and added 0. So 8 times 8 sevens are 56. The remainder is 4, include 0 here. 5 times 5 7 is 35. The remainder is 5, include 0. So now 7 times 7 sevens are 49. The remainder is 1, include 0. 1 7 is 7. Remainder is 3, include 0. 4 sevens are 28. The remainder is 2, include 0. 2 sevens are 14. The remainder is 6, include 0. Again 8 times 8 sevens are 56. From this point it is repeating, it start repeating 8, because 60 by 56, the remainder is 4. The same thing you are going to repeat here, the remainder is 4. So this 857142, it's going to repeat again 857142. Are able to understand? So similar way you have to find it for the 12 by 13 also. So 12 by 13, start dividing. 0 point, include one more 0 here because it is less than, so you have to make a point in quotient place and add 0 in this dividend. So 9 times 9 13s are 117. So remainder is 3, include 0 here. 2 13s are 26. The remainder is 4, include 0 here. And 3 13s are 39. Remainder is 1. So include 0, again it is less than 13. So you had 0 in the quotient place, keep it in mind, you had 0 in the quotient place and add 0 here. Now 7 times 7 13s are 91. The remainder is 9, include 0. 6 13s are 78. The remainder is 12, again equal to 0. So now it will repeat 9 13s are 117. The remainder is 3. That the step is again repeating here. So like this you have to find what is 6 by 7 and 12 by 13, like this method. After finishing this, you can write it as 6 by 7 equal to 0.857142. This 857142 is repeating, recurring. So you have to draw a bar in that. And also 12 by 13 is equal to 0.923076. 0.923076. Here 923076 is recurring. So make note of that. Therefore, the two irrational numbers are 0.8. Here 5 is there, the next number is 6. 86166 11666 111. Just for our convenience we can write it out. After this 8586 is there, now you take 87. 0.87177 11777 111. Just like that we can write it out. This is the two irrational numbers between 6 by 7 and 12 by 13. The next subdivision is third subdivision, root 2 and root 3. We have to find what is root 2 and what is root 3. Now root 2 is equal to 1.414. It will moves on, it will goes on. It is an irrational number. Similarly, root 3 is equal to 1.732. It also goes on. So both the numbers are irrational number. Therefore, the two irrational numbers between root 2 and root 3 are, you take the next number of this 1.4, it is 1.5, 155, 11555. Just like the previous sum, you have to add 2 5s, then 3 5s, like that you have to change, goes on. And after 1.5, what is the number is there? They are very good. 1.6, 166, 11666. It goes on. So these are all the two irrational number between root 2 and root 3. Now we'll move on to the next question, that is find any two rational number between 2.2360679 and 2.236505500. So here 2.236 up to this it's same 2.236, here also 2.236. After that number only it's 0, it's 5 here. So you have to keep it in mind which numbers are repeating between these two rational. So here look at here, the two rational numbers are the repeated number you have to write 2.236, it's repeating in both the numbers. So 2.236, after that you can write 2, there it is 0 is there, we are writing 2 here, and 2.2363. So these are all the two rational numbers between the two irrational number. Up to that the exercise is over. Now we will move on to the next exercise. Now we will move on to the next exercise, that is exercise 2.4. First sum. Represent the following number on the number line. These are all the numbers. This is a rational number, but from this onwards it is irrational numbers. Up to 3 decimal places we are asking. So even though it is a 3 decimal place, this 6.4 bar is an irrational number. How to represent this on the number line? So after writing this 5.384, we have to first say that this 5.348 lies between 5 and 6. Obviously it is lies between 5 and 6 because it is 5.348 lies between 5 and 6. What we have to draw? We have to draw a number line. I am going to draw a number line. Draw like this. So since it is between this 5 and 8, so I am going to write here it is, so 5 and 6, minus 1, 0, 1, 2, 3, 4, 5, 6, 7. So it is lies between this 5 and this 6. Are you agree with me? This 5.348 lies between the 5 and the 6. So what I am going to do, I am going to expand this 5 and 6. Listen carefully. I am going to expand this 5 and 6. Like this only you have to draw it. If you expand this, what is meaning of expansion? Here you have to put this 5, this 5 you have to put it here, and this 6 you have to put it here. After the 5, what the number will come? 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9. Then after 5.9 it will come as 6. Are you able to understand this? This 5.348 lies between 5 and 6. So in the number line I have expanded this 5 and 6 as 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9 and 6. Are you agree with this? Yeah. After this 5.34 is there. Where this 5.34 will come? It will come between this 5.3 and 5.4. Are you agree with me? This 5.348 will come between 5.348 will lies between this 5.3 and 5.4. So what I am going to do? I am going to expand this also. I am going to expand this. So this is another number line. In this number line, what I am going to do? In this first number I am going to write 5.3. In the last number I am going to write 5.4. In between how many numbers will come? Yeah, we will check it out. 5.31, 5.32, 5.33, 5.34, 5.35, 5.36, 5.37, 5.38, 5.39, 5.40, it is nothing but 5.4. Are you able to understand how to write this one? 5.3, after the 5.3 it is nothing but 30. 5.30 it is nothing but 5.31, 32, 33, 34, 35, 36, 37, 38, 39, 39, after 39 it will come as 5.40. So now we have to check where this 3.584 will lies. This 5.348 will lies between this 5.348 will lies between 5.34 and 5.35. Are you agree with me? Yes, this is lies between 5.34 and 5.35. So what we have to do? We have to expand this also. Expanding means this number we have to write it first, and this one we have to write it in the last number as a last number. So draw a number line. Draw a number line. Now what you have to do? For the first number, you have to write it as 5.34. The last number you have to write it as 5.35. What will be the numbers between these two? So this number is 5.341. 1, 2, 3, 4, 5, 6, 7, 8. I will draw one more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The next number is 5.342. The next number is 5.343. The next number is 5.344. The next number is 5.345. The next number is 5.346. The next number is 5.347. The next number is 5.348. The last number is 5.349. So here we arrived at the number is 5.348. You check it, our number. You check it, our number 5.348. Here we are arrived at the number 5.348. So this is our answer. Like this only we have to represent this on the number line. Clear, children? The next two sums we will see in the next class. Thank you, children.